In this BocaPhysics video, you'll see a set of simulations of the equipotential surfaces due to several point charge configurations. On an equipotential surface, all points are at the same potential. Recall that the potential due to a point charge is inversely proportional to the distance from that charge. In this simulation and all that follow, we'll assume that the electrostatic potential is defined with respect to infinity. The first configuration is comprised of a single positive charge. 5 contours in one plane due to the charge are plotted. The colors give an indication of the magnitude of the potential, and notice that each of the contours has the shape of a circle. If we consider the equipotential surfaces rather than contours plotted in a single plane, every surface will have the shape of a sphere. Only a few contours have been plotted in order that you can see inside the nested surfaces. The next configuration is comprised of a positive charge and a negative charge. 10 equipotential contours due to the two charges are plotted in the same plane in which the two charges lie. Notice that close to each charge, the contours appear to be nearly circular. But as you get further away, there's increased distortion. And notice the flattening that occurs in the region of space between the two charges. At the midplane, the potential is equal to 0. No contour will enclose both a positive charge and negative charge. And here's what the equipotential surfaces look like. The third configuration is comprised of 2 positive charges. 10 contours due to the two charges are plotted in the same plane in which the two charges lie. As in the simulation of the positive charge and negative charge, the contours close to each charge appear to be nearly circular. However, notice the difference between this simulation and the previous one. There's elongation in the region of space between the two charges. Eventually, the contours will join, forming a single contour that encloses both charges. And here's the simulation in 3 dimensions. The fourth configuration is comprised of 4 positive charges. 16 contours due to the 4 charges are plotted in the same plane in which the charges lie. We see that the contours exhibit the same kind of behavior as in the previous 2 simulations. The contours closest to the charges appear to be nearly circular, although it can be seen that the contours corresponding to smaller potentials are not centered on the charges. As we investigate the behavior of contours that correspond to still smaller potentials, we see that they will now enclose 2 charges instead of just a single charge. And eventually, as we investigate still smaller potentials, those contours will enclose all 4 charges. And here are the surfaces. The fifth configuration is comprised of 2 positive charges and 2 negative charges. Starting the first quadrant and proceeding in a counterclockwise direction, we have a positive charge, a negative charge, a positive charge, and a negative charge plotted here. Only contours that lie in the same plane as the 4 charges are plotted here. Because of how the charges are oriented with respect to each other, each equipotential surface encloses only one charge. And notice too the flattening that takes place in the region of space between two opposite charges. And here are the equipotential surfaces. The sixth and final configuration is comprised of 3 positive charges and a negative charges. Only contours that lie in the same plane as the 4 charges are plotted in this simulation. The surfaces that enclose the negative charge enclose only the negative charge. The equipotential surfaces corresponding to larger potentials enclose only one charge and are nearly spherical. As we investigate the contours corresponding to still smaller in magnitude but positive potentials, the contours become more obviously distorted. And eventually, those 2 contours will join, forming a single contour. Because the 2 charges on the right-hand side are close to each other than either of them is to the positive charge on the lower left, we see that the 2 right-hand charges are enclosed by the same equipotential contours. And finally, if we look at still smaller potentials, we'll see that the contour will enclose all 3 positive charges. But no contour will enclose all 4 charges. And here's a simulation in 3 dimensions. To summarize, the behavior of equipotential surfaces due to point charges. 1. No equipotential surface will enclose charges of opposite sign. 2. Every equipotential surface is a deformed sphere. 3. There is flattening in the region of space between charges of opposite sign. The limit of this flattening will be an infinite plane at potential 0. 4. There is elongation in the region of space between charges of like sign. The equipotential surfaces corresponding to incrementally smaller potentials becomes more and more elongated until the 2 surfaces join, forming a single equipotential surface.